The past 7th of December, we, the high school students of the Victoria School, got the marvelous chance to know and understand the salt mine of Zipaquirá through the eyes of science and technology. Therefore, me, Juanita Rubio, Sofia Jimenez, and Sofia Castro want to share with you our approaches to biology, physics, and chemistry regarding our visit and acquire knowledge from the salt mine of Zipaquirá.
Salt, an essential element necessary for all animal life. Thankfully, this natural resource is abundant here on Earth. We can find it in the oceans or in salt mines that form in our planet. But now, how do different organisms adapt to salty environments? Well, different organisms adapt in different ways. For example, fish and reptiles, they eliminate the salt through their gills. Birds and mammals, they eliminate the extra salt through the nasals into the nasal cavity. And plants break down the salt into chlorine and sodium ions. On the other hand, sand can form giant rock formations, called stalactites. This happens when old ocean seabeds that have long since dried up contain rock salt. The chemical comes from a body of seawater that has gone through a rapid evaporation process, leaving enormous rings of sea salt behind. The salt layers are then buried by sea sediment after a long period of geologic aging.
Salt mirrors are created when a thin film of water gathers on a vast plain of a salt deposit. Salt mirrors have both reflection and refractive properties. Reflection properties they have are when light in salt mirrors reflect because of the combination of salt crystals and water. And for refractive is when refraction also applies because of the change of direction of the light wave passing through the air in the water. Well, refraction is the change of direction of a wave that is passing through one medium to another caused by the change of speed of the wave. And reflection is the reversal of a wavefront's direction at an interface between two medias so that the wavefront returns to the medium from which it came.
In the mines, there is a so-called fool's gold, which is in reality not gold. It's technically known as pyrite or iron sulfide. The darker colored rocks that make up the salt mine are actually a result of impurities in sodium chlorine, NaCl, and that's why we don't see all of the walls in the tunnels as white, but instead pigmented with grayish tones. High microlomite quality, high sodium chlorine concentration, high microbiological purity, negative ionization, and low natural radioactivity characterize the air in salt mines. The bad smell in the mine was actually caused by sulfur or azufre as we know it. However, pure sulfur is not smelly. The bad smell is caused by the presence of graphite in the minerals, but most of sulfur's compounds smell horrible, almost like rotten eggs.